Hello there, and welcome back. My name is Al, it says right here, and this is lesson number 29. Is it a bug or is it a feature? And by that I'm actually referring to this hypothetical command line having to do with those string scanning Intel instructions, which have a strange behavior, which some might call a bug and others might call a feature. However, before talking about that and some of the weird behaviors of this function, let me just try to explain to you why this question has come up, for me anyway. Do I have that here anymore? No. Where's that going? Yes. Well, actually, see this is not really the starting point. Question I had, the first question, and I should have started it this way. Which is related to that outline. So window, open, review. Here's my hypothetical algorithm for parsing, doing the simple parse, throwing away what I currently had and trying it out this way. First, strnlen. I was thinking about strnlen and the comments I made last time about how strnlen, the C runtime function, has a lot of similar behaviors to that SCASB thing. So I just noticed that strlen is something like that scan for string byte, where in this case the byte being scanned for is a 0. And I remembered something that when I was working on this project I now have on the back burner, there was an object, a type of string object. This is a C++ thing, and we haven't really gotten to C++ yet, but the idea is quite simple enough anyway. You can declare these these objects, and one type of object is supposed to represent a string. Let's just, for the sake of convenience, call it string, maybe in lowercase. Now, you can declare these things just like you declare an int. So, imagine this is like int, and you declare one, you give it a name, my string, something like that. Just as you would declare an int, like that. Okay. And just as with an int, you can initialize an int when you declare it, like this. You can do the same thing with these strings. Okay, so there's a lot of similarity in these two statements. You're allocating some memory, maybe from the stack, definitely, and initializing the object with a string value. Now this is a C string. That is, it ends with there's always a null terminator here. And this is a string object. Well, this particular type of string object, the one that was being used in the project, comes from a standard library, and it has a special name. In fact, this is not the actual name. This is something that's built from their string object. But that doesn't matter, because you can name anything. You can name a thing anything you like. But I had assumed wrongly that these strings represented C strings. And so several times in the code I was using the fact that there is another way to declare one of these string things. You could say string my string, and then maybe pass a C string argument. Suppose I had a C string, regular string, and I don't know what this is equal to. It came from outside. I don't know. Maybe I called a function and it returned this. So I don't know how long this thing is. And I saw that one way that I looked in the help file and in the header file, and even in the compiler, as you're typing things in, it can give you hints and suggestions. And one is that you can put the string here, in this case called PC, and a number, a count. So it's some sort of count. So I might say 15, because I don't know how long this thing is, and if it's maybe it's not null terminated or something like that. So I only want a little bit of this string, because I only wanted to display a little bit of it. I didn't want to copy all of it. So I figured that if this string had a length of 1, let's say, that my string would have a length of 1. But that's not what happens. If you try to find out the length of this string, it gives you the answer 15. And that's not what I expected. So the only way for me to know how long this thing is would be to call strnlen. But then I don't know for sure if this thing is null terminated. And I thought and thought and thought. And eventually I found this function called string, the perfect function, strnlen. So it takes a string argument, const char star, and an integer value, maybe an unsigned int or something, maybe a size type, and it returns probably the same thing, something like that. And what this size type is the maximum number of characters that it's going to scan through, this strnlen will scan through before terminating its scan. So it'll either return the length of the null terminated string when it hits the null, or the maximum size, which is exactly the behavior that I wanted for my algorithm. That brings me back to this initial question. Is it a bug or is it a feature? No, that one down here. Well, if you look in the help, here's the actual help for that function. You can read it all right. See how well lined up that is. Yeah. Okay, strnlen. So exactly like I said, it's a const char star and a size, and then here is the information on it. null terminated string, size and buffer, etc. Return value. Now this is the part that is a little bit confusing. Fit this in. So turns the number of characters in the string, not including the null, if there is no null terminator within size of bytes, then size in bytes is returned to indicate the error condition. Now, see, to me, that sounds like a feature. It sounds like exactly what I wanted, in fact. So they're considering that to be a type of bug condition, and I'm thinking of that as just a second way to, that a string can be terminated because of some kind of boundary condition. So that's fine. That's the function I wanted. Why did I want that function? Well, let's go back to my algorithm. Suppose we had that function, strnlen, that behaves exactly as they explained. Okay, so we terminate, and it terminates on a space or when count becomes 0, like using the SCASB thing. Okay, and then what we want is that function returns the number of characters it read, not including the nulls, that's not including spaces, or the maximum value that it could possibly have read. Perfect. So that means there was no need to check for line things. And here's the algorithm. So first we check to see if the value at 80, remember this 80 thing, that tells us the number of characters there are on the command line. And if that's 0, we return. So then we advance to point to position 1. So we go to 1, and now we're pointing at the command line. Not the line, the line. Okay. Next, call strnlen. Okay. Now, if strnlen returns the remaining bytes, the length that we've retrieved from 80, remaining bytes. Why this thing is asymmetric? If that's the remaining bytes, they would just copy the rest and we're done. Otherwise, otherwise it might return 0. That's a possibility. In which case we move on to the next byte. Then, so that's the first case. If strnlen is not equal to 0, then we copy the number of bytes that it told us to copy, put it in the data storage, advance our current position, and repeat. And that should be it. There's no more horsing around or scanning for the next non-space and all that. A very simple algorithm, may not be efficient, but efficiency is not what we care about. When we're only scanning through a few bytes. So we calculate strnlen on every single byte. And when strnlen returns non-zero, copy however many bytes it says, And if that happens to be all that are remaining, then we're done. Now that is I think, is a fail-safe, 100% guaranteed to work function. And it relies on this function behaving properly. And that leads me to this problem. The logo. Close window. This question. How the behavior of this SCASB thing, which is not exactly what I had expected. In the meantime, I might also add that I wanted to be certain that the command line that's passed in actually contains a carriage return, because I thought that maybe I might have to check to see if we landed on a carriage return. And in fact, we don't have to check that. There's nothing in the code in the end that does that check, so that was a waste of time. But during that so-called waste of time, I invented I came across this problem. I wonder if I can make it happen. Oh dear. No, I don't want to save it. No. Remember this batch file? I wanted to see just how many bytes I could actually type in. Now, do I still have the program? Okay, well, my prog is fine. So how many is that? 20? Well, go by 10. 10, 20, 30, 40, 50, 60, 70, 100, 10, 20, 30. So that's more than I'm allowed. That's 130. So it said I could have 110 or something. 126, I think, was the maximum according to the help file. I'll try running this batch file. Cannot execute program. So I'm thinking that's weird. I should be able to take that many, and so take some off. Now let's make sure we know how many there are. Let's start over again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. 10, 20, 30, 40, 50, 50. 100. Okay. So this is 110 where the cursor is now, and here is 120. So you have to agree, I hope you agree with me, that that's 120 bytes. Okay, go. Cannot execute program. And I'm thinking, this is pretty strange. Can't do 120. It said I could do 126 at least. So we'll try even fewer. So now it's 110. Go. So it managed to do 110. And there it is. Well, actually, 110 and here on this line. This here is left over from another experiment, it turns out. These would have been cleared normally. Because, let's see, that's E0. If I want 110, that's 6E. 10, 20, 30, 40, 50, 6. And if you take away this, if you start from this spot, E, so this would be 6F. 10, 20, 30, 40, 50, 6F, 6E. 20, 30, 50, 60, F. No, 6F, right? And so that's 6E. And that, it says right here, 6F are the number of bytes. And I typed in 110, but I also typed in a space. Now, so, okay. So now go back to the batch file. And see how many we can add to that. Try adding 5. Go. Cannot execute program. I'm going to try 3. It's sort of a almost binary search. Cannot execute program. So it's pretty, the help doesn't seem to be telling us the right answer. Now it's just one more than the 110. Whoops. Go. Cannot. In fact, just by pure accident, we hit the maximum 110. What? Couldn't do that? Oh, I added a 0. It's still the extra 0. So it looks like the maximum is 110. And then I thought, well, maybe if I look at this command line, it's really the command line of the debug program. It's got all these extra characters on it. So then I tried copying the debug program and making it the name smaller and so on. And then I thought, okay, well, I'm just going to see how much it can take without running it under the debugger. And actually what it's going to do is you're going to see what it... Let me just do something first. Let me try and clear this out here. I don't know, some random number. Not 0. Well, 0's, yeah, 0's fine. Okay, now, if I type my prog debug, oh, it's at a different address, maybe. Oh, it's got all those stuff still in there. Didn't I just fill from 80 to... Oh, no. Should have been filled up. Eight. That's a 0. Yeah. That's 0. Now they're back again. Well, that's weird. I'm not sure why that is. It's the same segment. If I make a new box, I want to clear all that out. Okay, there we go. Okay, nice and clear now. Because what I did eventually in the end, because I saw that it could take more characters without running under the debugger, I made a little thing that prints out this style of printout for the command line. So now if I run my crawl, I can type in more than 110, but I still can't do 127 or 126. So that's 10, 20. I'll actually run my copy from that batch file. Can I copy it that way? Look at the scroll though. I can get a good number of them anyway. Oh, what am I doing? Notepad. Show you what I'm doing. Five, 6, 7, 8, 9, 10, 11, 12. 12. 12 is more than it allowed in the other. Will it take that? I think it will. It did. This is my own printout because I couldn't see this. I couldn't see it go beyond this point under the debugger. So now it did 120. This is the PSP80. This is, I don't know, this is my own thing. Yeah. This is the result of the parsing. One null terminated string of this length, whatever that length is. Here's the command line. It goes up to a 39, and as you can see, the parsing actually works. We haven't got to that yet. First character is a 30, but anyway, it made it all the way here to 120, and I think that's the maximum it does. Yeah, it won't do any more than 120. So the maximum number you can have here is a 79. Well, I thought I had 7a in there at one point. No. 79. I'm not sure I have. That looks right though. That looks like as far as it went. I thought I had 7a. For some reason at some point. Not important. We'll have a look at this code, by the way, that prints this out. It's got some interesting little features to it. Now, so all this together, by the way, just demonstrates to you that I did, in fact, solve this parsing problem, and it works for any possible case you can think of. Spaces at the end. Here's the result. There's the comma. Each thing separated by a single 0 and placed in this nice table like this. All I had to do was get that strnlen thing going. I would start with this, and then I would see if I could do that. And it took hours and hours and hours. because the behavior of that SCASB is very strange. It doesn't return exactly what you expected, or what I would have expected. in different scenarios. But it's not too bad. I thought I wouldn't have to have exception test for exceptional cases, but you have to. Turns out that if you start out with CX being 0, then you get a different answer than 0, and that's no good. I mean, using the same logic. The easiest thing to just, for the case of 0, is just don't do anything, return 0. Also, if you start out on the delimiter, you don't get the same end result as if you started out on a non-delimiter. Presumably because it never has a success test, so the DI doesn't get updated. It just sort of falls through and does nothing. And then, of course, there are the cases of the length being either it quits by length or quits by finding a terminating character, which gives the two different results. And trying to get all of them working with the same logic, I think is impossible. The SCASB function, when it terminates, has sort of multiple answers. Now, what have I got here? Yeah, you have to do a comparison when it terminates. And the comparison I found that is the one that tells you what the answer is. How many characters did you read according to this strnlen documentation, which is the function that I want? Depends on whether or not the previous character was a terminating character. That the byte that's in the accumulator. If that's equal, if the previous byte is equal to the accumulator, then the single decrement that means that we were one beyond the length. If it's not equal to if those are not equal, that's the CX being 0 case, which you could also check for. I mean, CX is the count here that I passed in to the repeat. You could assert here that CX is equal to 0 on this line. In that case, DI actually contains the string length. And it took me quite a long time to figure just this part out. But once that part was figured out, the actual code itself is quite easy. And here's the code. First, I'm using the space as my terminating character. And then I get the command line length from 0, 80, offset of the command line. Now this initial increment just makes this loop consistent, because there's always the first step here, there is a decrement in count. So I have to just comment here as a fake out increment. So that by the time we're here, CL will contain the remaining characters, which is what we want. Source offset is going to be in the BX register, so that we can dereference it. And the destination, I just decided that will be in DI. That's where the storage area is that I've been printing out using the memory dump function. Okay, so this is where all those null terminated string scale. So now this is the entire function. There's no more to it than this. So first, decrease our counter, advance our pointer, check to see if there's nothing left. If there's nothing left, we're done. Now remember that this strnlen takes a pointer and a counter. So that's if you push in reverse order, counter first, because that's the last thing that appears on the command line or on the parameter list. I don't have it in here, do I? I must. And here it is. Reverse order, count, then pointer. So push the count, push the pointer, call strnlen. Fix up the stack. AX, this is an integer function, so it returns the length. If AX is 0, then we jump to go and look at the next character, just like I was saying. Now, eventually it's going to return non-zero, or we're going to run out of characters and quit here. Okay. Now the next bit here is a little trickery. It's not really trickery, it's just that I want to have you see, I have to subtract this returned value, the AX value, which is going to be less than 100, from both CX. I subtract it from CX and add it to BX, right? But I didn't want to do it I can't increment BX at this point because I'm going to use BX for this mem copy. So I could subtract from CX or CLow the AX return right here, and then do BX in a different spot. But I thought that it's a better idea. It's always good practice to do them together, just as they are together here. It's easier to read. So what I've done is just take advantage of the fact that it's only bytes. So I can save off the value AX in the upper part of the CX register. And then now that's fine for this mem copy. And all this part is doing is just copying the string to the data storage. And remember, this mem copy returns the updated value of the destination given in. Remember the useful return value. So all I got to do is to update my new destination pointer is save off AX and add 1. Null terminate. Now in C-high, I've got saved off the amount copied. I add that to my BX. All these are less than 80, so I have extra registers. I subtract that from CLow, return CX's high bit to 0, check to see if there's nothing left, otherwise advance to the next counter. Now this is going to do another increment of B and decrement of C, but that's fine. We know that we're allowed to do that at this point because the thing terminated. If it terminated, we're either on a terminating character. We couldn't possibly be at the end of the string because this would have been 0. So it's safe to advance 1 extra character. And as you saw, it worked. Now main here is just using that function I told you about, DOS debug dump, which I'd like to show you a bit of how that works, because it has some it uses some interesting little tricks and things. And that's it. There's nothing else to this program. The command line parsing is done. But we should step through it and have a look and watch it in action. I'd like to do that. But first I'm going to pause. And once again, I've used too much time up. So you've seen the outline of this, and you've seen that it works. And I've told you about the weird behavior with the SCASB, and that it has several behaviors. Some people might call those behaviors a bug, other people might call them a feature. In my case, I'm taking the strlen return value from my strnlen, wherever it went, as a feature, because working this out solved all the problems, and you know for sure that there is no possibility of fooling this algorithm, this method. It's just going byte by byte by byte, and there's no way that anything can happen to break it. So that is 100% solid. Now that that's 100% solid, I can move on to the next stage and use this fact to try to construct a solution for every possible command line. Okay, and I'll save that.